Hi, Ashin. Okay, now you are able to see, right?
Yeah, yeah.
All right. Okay, sure. So we'll make a start. So today, what now? I think what we're going to cover is mainly, we are going to cover about software architectures. So basically, we will not jump into the the latest software architecture. So how the industry or the people are moving into the new infrastructures and the new architectures, and we are not moving to the new solutions upfront, but we will see very quickly how this software architectures has evolved. So mainly from the two-tier to the three-tier, multi-tier, and to the serverless, and how what are the benefits of each architectures, and how what are the pros and cons, and basically what are we going to cover part of our program as well. So mainly in very high level, what are we going to cover is mainly we will cover about the architecture overview, and then jump into kind of like a two-tier architecture, and three-tier. Three-tier is kind of like the most kind of like a famous or highly been leveraged architectures for until some time. Then why industry or the people are moving into multi-tier architectures, what are the benefits as well, and then kind of like the latest trend, especially about serverless. And so these are the topics I will cover, and then Kapil will cover about give a quick overview of CI/CD, why what is CI/CD, why it is important, and how software integration, software delivery is important to the business, how it can assist. And then he will do a detailed walkthrough of so the entire this program, right? So this DevOps program, we are planning to do kind of a POC way, that is like a proof of concept. So so basically we are putting these foundations to get you into a certain level. From that onwards, it will be more of like we are going to implement a POC solution, which is using all the key or the main DevOps the technologies. So idea is that so we will not do it in a big bang way. So that initially it would be more of like maybe give a quick POC of CI/CD, then maybe a setting of a Kubernetes cluster, or maybe before that we might talk about microservices, and then setting up a Kubernetes cluster and deploying microservices, and then bringing up these other supporting services, so that we can kind of do a comprehensive uh, like you know walk through and get you also hands on into this as well, right? And plus today we are going to do a quick CI/CD demo where Mohan will walk you through using AWS services, how you can actually even set up a quick demo instance, and get all those get your hands dirty with the technologies and other things. Okay, so moving on, so this is kind of an introduction to kind of like the software architectures, how things have evolved, right? So if you look at maybe even 20 or 30 years back, right? So it's like the one of the main thing the when people are talking about software as is, it was more of like a monolith, right? So we say it's monolith architecture. It's a maybe a one unit one, like maybe it's like it's the uh, uh, again, like if you take a step back, if you take any software problem, right? If someone asks you to develop a system for a particular business need, obviously it will revolve around data, right? So maybe it's about you inputting data, and then obviously you will have to go and save that particular data, and then the on top of that save data, you will apply some logic, and then you will generate some new format of data, which again you will have to store, and then you will have a presentation layer, right? So people view your data, right? So mainly the key aspect is your data, and then on top of that, how you going to present this, right? So probably you might have the input screen, the update screen, edit screen, delete screens, likewise those are the basic things, right? So very early, right? I can still remember, like when I started, we used to have kind of like our the systems are very much integrated with the database as well, right? So maybe there are we used to Access is one of the things I can remember, where we used to have the forms as well. So it's more of like very aligned to the database. So that's why we are calling it a more of a one unit structures. So then, people realize that, one unity structures, are a little bit of, clumsy, cluttered. It is not very easy to work with them. So we move into more of a 2-tier architectures. So 2-tier architectures are mainly separating out your data and your logic. So we are storing data in our databases, and then, we have our logic layer or the presentation, everything. So we are actually separating this, 2 layers, right? So then, over time period, we realize that, that is also not enough. There are, good pros and cons to this, but because of some other challenges and some other needs from the business, we came up with this 3-tier architecture. Like, very high level, it's your presentation layer, it's your business layer or the logic layer, and third one is your data, right? So we segregated these layers so that allow us to build a more scalable, more high available software solution to the business needs. And then again, when the time comes, internet was growing, right? So there were a number of users, the lot of now it's internet is more of like it's in your hands, like your mobile phones, iPads. So many people are using, accessing. So that means like the softwares, we have developed over the years, used to get more number of users accessing. So the demand is high, so things has to be scale. So that require a lot of challenges. Like example, uh, people realize that caching is very important, right? So we can't, let the very recurring request go into the database, like, because it's a expensive operation. Probably if I can figure out a way to serve that request in without coming into my lower tiers, then I can do a much fast response, right? So because of that, the multi-tier architecture came in. So that's again, it's again have its own advantages and disadvantages. So mainly here, then the idea of the microservices also came in. So instead of, having a very big big module, one big module of application, you break your application into different pieces. So I can remember, like, when I started, we used to have a probably not one big module, but at least 1, 2 to 3 maximum, right? So maybe but still there's a one gigantic module, right? So that module hosts entire our, all aspects of our application, each and maybe admin modules, maybe different functionalities of business, the authentication, authorization, so everything, right? Probably scheduler, kind of schedule jobs and all is still, a little bit of isolated, but still it's a gigantic module. And if I want to do kind of a one piece of changes, example, assume that, I have to do a small change in a particular module, I might still have to go and, redeploy the entire thing, right? So that will result in a outage or to the customers, right? Customers will not be able to access during that particular time. And one other thing is, because now my change is applying to the entire module, right? That gigantic module, there's a chance that, I can break something, right? I can introduce a new bug to somewhere else, right? And again, that involves, testing and those. So the effort involved is so less, right? And even if I want to do a certain change, the impact is high, right? So that's why, microservices came in. So we want to break our gigantic modules into maybe a different small domains, so that, now if I want to do a small change, I'm only going to touch upon that particular domain, that module, and then I can deploy that domain, so that it will have less impact to the overall the ecosystem of our application. So we call that, the blast radius is less, right? So for example, in a gigantic application, it's like nuking, right? So your that gigantic application is down, then entire system is down. But now in microservices, it's different small modules, so that if one piece of module is down, there will be a impact, but that impact is still less, right? So that's why, so while we are moving from monolith to so from one unit to the multi-tier, we have been moving from this monolith to microservice as well. So that's a quick overview of microservice. So we will have a one session, we will walk you through microservices, and also trying to create like a microservices, from the ground up as well, right? So again, one other thing I have to highlight is, until now, right? So this until one unit to multi-tier, we were, so there's a example, if you guys were the developers, you guys had to be mindful of your infrastructure, right? Example, if you develop a small web application, you might still have to deploy that to Tomcat, right? And maybe Tomcat has to run in a particular the physical server or virtual server, something, right? So still all these solutions are very much integrated with our infrastructure. So that's why uh, especially the theme of DevOps also came. Like we have the developers, we have the people who are doing the operations, and one of the big thing is managing the infrastructure, right? So now the world is also a little bit, and when you are coding, you have to be also mindful of what infrastructure I'm going to use, and handling infrastructure is a major part of the entire piece of maintenance work, right? So we have the application maintenance, which is our coding. We have the operations maintenance, manage making sure that application we have code is deployed and maintained. So infrastructure plays a key role, right? So serverless is moving away from infrastructure. So we are thinking, we are trying to figure out, can we not worry about infrastructure at all? I might only focus on my business problem and come up with my solutions, so that I deploy in some place where managing the infrastructure is I don't want to take that burden, right? So that the high level is it's serverless, right? Without a server, right? So that is the direction we are heading. So here, in summary, is that and then because of with its own complication, now we are moving into more of a serverless, right? So that is kind of the high level journey which we have taken, right? So if I take a pause, any question here, anyone? Okay, so I'll move on. So we'll quickly discuss about what is a 2-tier architecture, right? So as I said, 2-tier architecture is separating your data, right? So and then you still you can have something up and running, right? So again, what the key thing to point is, you will have to think about your database, how you're going to deploy your database, and you will have to think about your application tier, and that this will have its own advantages and disadvantages as well, right? So mainly advantages is simplicity. So it's a very simple architecture, right? So anyway, so basically it can be your PHP, MySQL, Tomcat, or Apache, the combination, or very like very simplified solution. Or maybe we can even build a 2-tier architecture with the AWS as well, right? So maybe you bring up a two EC2 instance. One you put a database, and other one you have install maybe a Tomcat, right? And then you put your code base, and you can have it up and running, right? So it's very simpler, right? So it's not complex. So it's an answer to a lot of the business problems, right? And it's again a good performance, right? So maybe you'd have thought that from moving from one unit to 2-tier, 3-tier, and multi-tier, the performance would have increased and all. But again, and it doesn't mean that 2-tier architecture is a like a performance less performance solution, right? It's again because the requests travel through very less interfaces. So it's again like little bit like decent performance, and it's obviously a very cost-effective solution. And again, it allow you to access the database directly, so that then again, again that will have a ripple effect on your performance, right? So the disadvantages are lack of scalability, right? It's a little bit of difficult to scale, right? So again, it doesn't mean that this is a solution without scaling, right? So example, assume that we build this application, right? Assume that database is MySQL, application service Apache, and the database runs with the one physical server or VM, and application the Apache is running with another one physical server or VM, right? So this at concurrent, 10 users can access. And if someone comes and say, I want to double my capacity, right? I want to make it a two concurrent, like twice, right? 20 concurrent users. Probably, I'm saying hypothetically, right? Maybe we can add another the database and make it a cluster. And the Apache also a cluster server classes. So that will have a little bit of scale, right? So it doesn't mean that when we say lack of scalability, it's not no scalability, right? It has its a certain way of scaling, right? So we can have a database cluster. We can have a example, our application tier is like the WebLogic, Oracle WebLogic. So then we can have kind of a Oracle WebLogic cluster, right? And so it's again like it facilitate you know certain level of scalability, but it's not enough, right? So that's what we are trying to say, right? So then it's again limited fault tolerance, right? So example, if your FTA is down, then probably you are down, right? You can have a scalability solution, multiple servers in your application tier, but still if there's issue, then the fault tolerance is less, right? But you don't have much way of playing around with when it comes to fault tolerance, right? And then it's again very tightly coupled, right? So any layer, any issue in any layer, that will have a direct impact on the other layer, right? Example, your AppTI is having issue, then obviously it will have impact on your database tier, right? And there's a connectivity issue between AppTI and database tier, that will have a ripple effect, right? Probably your application is completely down, right? So that's again one of the weakness, right? The other one is the security, right? Because it's a two level example, if this is a bad actor, right? They just have to go past the application tier, then they will have the uh, okay. So they will have the access to the database, right? So basically,
recording in progress.
More if someone is able to breach this application tier, they have a direct access to the database, right? So that is one of the major disadvantage when it comes to the 2-tier architecture, right? So because it's just a one level of security. So basically, here, so this is about, people talk about SQL injection, right? And people talk about the cross site scripting, and all those, like, the ways of hacking, and all those things are discussed up here, right? Because the structure is such a way that you just have to break one wall, and your database is vulnerable, right? So this is kind of like mainly why people are moving out from 2-tier to the 3-tier, right? It's mainly one thing is the security, second one is the performance, and not the performance, but more of a scalable, and also some degree of performance as well, right? Even though these are kind of like the process there, but again, I mean, there's a maximum limit, right? How far we could have the push this through, right? So because of this, we have been moving from 2-tier to the 3-tier architecture. So by the look of it, you will now realize that this make a little bit of sense, right? So it's again it has a part of how our 2-tier architecture was defined. So it has your database, and it has your application tier. On top of that, we brought in a web tier, right? So uh, so if I ask you a question, right? So how this improve performance? For example, if someone say 3-tier architecture, we can increase the performance. Like, so how do you think that 3-tier architectures are improving performance? Anyone? Anyone here? So you don't have to really like worry much, but like just any answers. How do you think that 3-tier architectures is speeding things up? Like how it's allowing us to like make sure that when someone's type www some website.com, that is helping us to load or render much faster, right? Any ideas? Okay, with microservices. Okay. That's again, yeah. Again, I have to say there's no right or wrong answer. So there's again microservices. Moving to microservices again will kind of like allow you to speed up things, obviously. But there's a more so again, what you have to understand is microservices are in this layer, right? Probably in my 2T architecture also, right? If I move into my previous screen, so there's nothing stopping me from bringing up a deploying microservices here as well, right? So probably I can do that, right? So it doesn't like there's no hard way of saying, okay, this here we don't have microservices, but here obviously microservices is a good choice that will help us to do certain degree of performance improvement. But just introducing this presentation layer, right? What is the advantage? Okay, so if I step back, right? If I step back, so assume that you have a web application, right? Maybe it's your kind of like it's your what do you call Google page, right? Everyone is familiar with Google page, right? So when it comes to Google page, okay, if you take that Google, tell me what like that particular page or at the application, if you can break into different aspects, right? Maybe by looking at that the page, what are the things you think you can mention? Like example, if we I don't know whether if I'm moving, you can see. So you have seen Google page, right? So you have that search box and you have the search buttons, and then you have a different like your language controllers, and there are other things as well. So if you look at it in a very close manner, you will see there are static content, right? Just because either I'm in Colombo or Peradeniya, that my static content will not change, right? If I'm access this Google from like Singapore, India, or US, again the static content will not change, right? The Google what do you call Google logo will not change, right? But maybe buttons will not change, the location of the but there are few things, right? Based on my language control, based on location, it might convert my language. So there are some dynamic content as well, right? So one key thing to highlight is, if you look at any application, right? If you go to Cricinfo, if you go to Facebook, if you go to like Twitter, if you go to any of your favorite website, content is always two part, right? That is your static content, and second one is your dynamic content. And one thing you have to understand is your static content is always static, right? It will not change, right? Your image is not change. Example, if you go and kind of like look at your the any of example, if you go to a news site, right? If you go to a news site, you will see you will see your you will see your what do you call the content is getting changed, right? You will see your images, you will see your headlines, you will see your breaking news. But so those are your the dynamic content, right? So those content change, right? But there will be your metadata of your page, there will be some logos, there will be some icons, there will be probably some hard coded things, those are your static contents, those will not change, right? Probably it will change, but maybe you will say, okay, so maybe advertisement, right? Probably they have hard coded it, but maybe after 1 week, when they run out of your agreement with the person who's advertising, they will go and come up introduce a new advertisement. So then again they will hard code. Maybe it might be dynamically picking up as well, I don't know. But generally your content is always two part, your static content and your dynamic content. So that allows us to play with this data. So what now people are doing is, so the static content, the content which is not changing, people will go and deploy it in your web layer, right? And your dynamic content, right? Dynamic content is more or less your the business logic related ones, you will go and deploy it in your application tier. So example, if you are creating a like a maybe a uh, the traditional web application, you will put all your images, your CSS files, and any other thing. Those are static things. Your PDFs and all those things are here, because those you don't have to like, and because when the user send a request, you don't have to go to application tier or database tier, right? You can serve that request from directly from here. So now when you are rendering that Google homepage, it doesn't mean that entire page will get rendered from your the presentation layer. But what I'm trying to say is, if you have seen like example any application, any the home page, there will be thousands of requests going on, right? So there's a higher percentage of those requests we can we can the response or answer from our presentation layer, right? So example, if I type www.google.lk, assume that there are 100 the request inside that generating to render that the Google homepage. Probably I'm assuming that 60 or 70 requests are to get some tiles, some HTMLs, get some images and those things. So that is much faster, right? So then you can get your you can we can cut down our render time, right? So assume that the entire Google was like here, right? Two tier, where it comes to here, and from here there will be database calls and everything, and then you are kind of like rendering that the page to the user. Here it's much faster, right? You can cut down that time because of that presentation layer, right? So that's one of the major advantages we have, right? So it is allowing us to do a caching, sometimes caching, and sometimes much faster response. And again, obviously, the security, right? So now it has, so example, now if this is a bad actor, this bad actor will have to break into this and here in order to access our database, right? Just because they were able to crack the presentation tier doesn't mean that they will be have a free access to database, right? So that's again a very good thing, right? So people will have, so it's more secure, right? And so, and again, now the scalability, right? So here we said, like, even two tier we can introduce clusters and all, but now with the presentation layer we can have even your static content also we can scale, right? So this allow us to have multiple web servers, this allow us to have multiple app servers, this allow us to have your cluster, database cluster, so that a single point of failure, a single not in a one particular layer will have a not a major impact. It will still have impact, but again, this is a very better scalable solution, right? So that, and other thing is now in your two-tier layer, your database or the app tier is getting all the hits, right? So you will have to have, example, if I go to the two-tier, you will have to have high processing power in your application tier, right? Because everything comes to your application tier, right? But now if I move into your the 3-tier architecture, because we are handling the high percentage of requests from our presentation layer, the number of requests coming to the application tier is much less, right? So that again allow us to speed up so that there will be more capacity here to support the execute your queries, right? The request, right? So that's again allowing us to, it will have a more faster response, right? So again, so scalability we have discussed, the security we have discussed. So fault tolerance is that, because if one single failure or a combination of failures will have less impact on overall availability, right? So because it's a lot of, most of the time it's a clusters environment, ETA is a cluster, so that something goes down doesn't mean that entire application is down, right? So that's the advantage we have, right? So again, one other thing is, now in example, in the 2T architecture, I am doing a deployment, right? If I shut down my application tier, there's no way for me to give any maintenance paid to customer, right? So example, if you are going to particular slide, so example, if you are using a banking site and your bank is going through a maintenance, they will say, I'm sorry, during from 6 to 8, we are going through a maintenance, so you will not be able to access your site, right? So how is that screen is created, right? So if they have a 2-tier architecture, then that's a little bit of problem, right? Because it's a little more challenging, right? This tier is down, probably then you will have to segregate, right? Maybe another lay another cluster or something. So it's a little bit of expensive and different. You'll have to put a lot of thought process into it. But now if you move into 3 tier, if we are bank and we are taking out our application layer, application service, whenever the traffic comes here, I can enable maintenance page. So every request coming from user, instead, now here I have a, so here this is proxy, right? So this is a proxy, so it's passing this request to application tier, and it is deciding to pass it or serve it from itself, right? So here I can stop all the traffic going down. I can put it, I can direct into HTML page where it says, I'm sorry, the system you are trying to access is going through a maintenance window. After 8 p.m., try again, right? So that is a better customer experience, right? And I can remember, like, some time back, right? Maybe 10 years back, one of the e-commerce application which I was involved, so that application, bringing down that application for even 1 hour is money, right? It's costing money, right? Because people come and they are trying to access the application, and that application is down, and we are giving them a very nice sorry page, right? We are sorry, try again. So people will move on, right? So they will move into different some other competitor to get that their requirement fulfilled, right? So what we have done is, so during this time where when we have a maintenance page, what we have done is we created another form, right? And form and integrated with another database, right? So people will redirect to a form where it says, okay, application is going through a maintenance window, but if you can give your email address and contact number, we will call you back, right? After, and then those data, either we can save it in a file or maybe another database. You have a lot of options. So once like, what happened is that next day or immediately someone will look at the mobile numbers and call them, right? We will have a call center team. They will go and call people and say, hey, I think you have tried to access our application during when we had the maintenance. How can I help you? Can I raise an order when on behalf of you? So still I will not lose this customer to a certain degree, right? So that is again a very good when it comes to business perspective, right? So this again have its own disadvantages. So this is complex, right? When you moving from another, so we are introducing a new tier, so it's again complex. So it has increased my deployment time, right? So instead of giving a deployment module, the deployment where the changes will go to database layer and application tier, now I have to deploy my changes in web tier as well, and this has to be synchronous, right? And so this is the overhead. And obviously, in order to support this, we will have to bring up new VMs or more physical servers. So this is costly, right? So these, but again, what we have understood is this example, the cost, overhead, and those things. Again, we can play around. We can develop this, enhance this tree in a better way. So that will allow us to get that advantages, right? So mainly the advantages are, we can have a more faster response to our end users. We can have a better way of managing customer experience. Example, system is down, we still have way of working through static pages to give some sort of a different experience to customer. And the security is very high, right? Probably you will not understand probably at this moment, but when you have an application with thousands of users accessing, bad actors will try to hijack your or bring it down, right? People will try to have send you a DDoS attack. People will try to do kind of like a SQL injections to get access to your system, maybe credit card data, personal data. So the security is very important, right? So this allow us to have a very tight secure system, right? So some of these disadvantages are very minor when you are talking about our advantages here, right? So here again, if I again summarize, so again you will have a cluster of database, a database cluster. You'll have a cluster of your app tier, and you can have your certain web server classes as well, again cluster, so that will have high availability as well, right? Any questions, anyone? Okay, so from here we will move into our the more complex solution, right? So again, over the years, what you have understood is that there are certain things like probably like on top of this, we were able to bring up a traffic tier, right? So basically, I can have a traffic manager, right? Which is handling traffic, and that will make this more of a 4-tier architecture, right? So now, if I ask you what are the advantage of 4-tier architecture, one of the key benefit is the security, right? So now, now here, this even this 3-tier architecture. So assume that we are supposed to this application is supposed to have access from Sri Lanka, right? So you are expecting maybe people from Australia, or maybe some Sri Lankans living in outside, access, but you are not expecting maybe people from Nepal or Bangladesh to access, right? Suddenly, if you realize that you are getting thousands of people request from Bangladesh or maybe China, those are kind of like not legitimate access, right? So maybe you want a way to block this access, right? Because that those are probably not legitimate users, right? So then blocking this access to a particular region, those are challenging, right? Probably you will not be able to do that, right? You might have to go into a internet service provider, or maybe it's still challenging, right? But if you have a traffic manager, that again gives you more control of your traffic, right? Maybe you can you can block those traffic, right? So I can still remember, there was another application which we have developed, which is again like a enterprise level e-commerce application, right? And then we there were example, if assume that if you purchase something, you are able to purchase something above a certain bill, you will about to get a coupon, right? And then there were some people trying to there may be a defect in the system, you might not have to go through the entire payment gateway process, but you will able to get a coupon, hypothetically, right? So then we understood that a particular day, based on that nature of orders, one particular IP will raise only one order, right? If someone is trying to raise a second or third order from the same IP, that is not a legitimate request, right? Based on that business context, we were able to derive that, right? So basically, from our traffic manager layer at that time, we were able to say that, okay, if there's a one particular order journey went through, stop that particular IP going through the second user journey, or we will limit it to the 5 user journeys, right? So if you have a 4 completed user journeys, don't go with the fifth one, right? We know that's next to impossible, right? So those are the advantage the fourth layer will giving, but instead of this fourth tier architecture, people more of discuss about it as a multi-tier, right? So multi-tier architecture is something like this, right? So this is again, this design I got it from one of AWS case study. So they are saying this is so this is for a web store, right? The web store, particular web store. This is the one of the solution they have given, right? So here, if you see, you have the users, the browsers. The people will come from the browser. It can come from mobile as well. So all the requests are coming here, right? So again, either next week or week after that, we will going to have a more of a AWS basic session. So we will cover about the basic the services of AWS, very high level. If I talk to you, Route 53 is nothing but handling the DNS. Right, it's more for DNS controller. So the request will first come to DNS. Here, we are able to kind of like have kind of a, AWS WAF module, which is taking care of the security side, and maybe the security, the firewall, and ensuring that bad actors are not able to crack your system. And other side is when you are looking at more for complex systems, the caching I told you about, the caching in the web layer is not good enough, right? You will have to go into more of a CDN. CDN is stand for content delivery network, right? Where the CDNs are developed more or less to handle the similar request, right? For example, even people like Google, right? So example, once that YouTube video is loaded, if there are thousands of requests comes in, it will support go through your CDN, right? It will not go into another layer, right? Because it's the same recurrent request, so that you can serve, right? So example, AWS, we have something called the cloud front, which is the CDN. So here you can see now the requests are come to your traffic layer, traffic components. It is going through more of a security component. It's going through your CDN, which is content delivery network. So it's a kind of like a already complex, right? It's a very complex setup, right? And beauty is request has not even touched your logic, or the request has not gone to your database layer as well, right? And now if the traffic pass through here, it might go into a load balancer. So that's again a traffic component which is able to load balance the request, right? So request is either going to your the your the Docker containers, or it can go into your Kubernetes setup, or it can go into your database directly if that is the case, right? So still there will be a lot of load balancing happening. So that's again very scalable solution, right? So this is your more of your web tier, right? So again, web tiers doesn't mean that it's only web servers, right? Now here you can see uh, Fargate. Fargate is like maybe like a solution developed on top of your containers. So this again like Dockerized solution. It can have your the Kubernetes solution. So web tier can be many things now, right? So and in between web tier, it can have your file system, elastic file system. So at this moment, don't worry too much about the AWS services. Probably you might not get it. Probably you might get a little bit of understanding. But this is all I'm trying to say is that the things of multi-tier and how complex it's getting, and with the complex it is able to do more of a high profile, it will able to present a high profile, more scalable solution, right? So again, you can have your kind of like API gateways. It can have your the application tier is again like multiple components. It can integrate your third party systems. There are a lot of other systems as well. So it's very complex setup, right? You don't have to remember, like you don't have to understand what is Route 53, or what is Fargate, or what is Elasticsearch, or anything. But what I want you to understand is it's going beyond our the basic 3D architecture, right? And another thing is the layers are not top down, right? It's not that your web tier, your the app tier or the DB tier. So now you see, like example here, maybe there's a 3D architecture in here as well, right? Here as well, right? So things are more complex, and there are a lot of interconnecting tiers, interconnecting components. So that's the beauty, right? So this allowing us, so whole idea is, so example, if you ask me, Indika, so what is this, right? So we are making life very complicated. You are throwing around a lot of names, you are throwing around a lot of components, you are making it more complex, right? So probably answer is that when you are having example, one of example, even in my career, right? I have worked with around maybe thousands of concurrent hits, right? So that's again, it's very complex, very demanding, but it's still doable, right? But if you have seen, like maybe last week when IPL final happens, right? So IPL final was hosted in the Geo Cinema, and that is again Reliance, right? One of the Mukesh Amban, right? Who owns the Mumbai Indians. They own, like they have, it's the conglomerate which is having so many companies, and one of them is Geo. They are the mobile service. So they got right to the IPLs as well, and they had uh, they created a one beautiful mobile app, right, which is called Geo Cinema. Anyone in India who's using the Geo, the service provider, just like in our, like maybe Mobitel or Dialog, if we are using that, then the data is free, right? So you can log in it, you can use that Geo connection, and you can download Geo Cinema mobile application, and then you can go and watch any movies, then you can go and watch the IPL matches, anything, right? So that's a, and because there are millions of users accessing, they were able to make a lot of money, right? And the example, if you are probably aware of, like Hosta and other the other companies, so they were losing money because these guys are giving a much cheaper solution, right? So when IPL finals happen, when Chennai versus the that Gujarati the Tigers, or their Gujarat team, there were 32 million concurrent hots to that particular application, that mobile application. 32 million. And that is insane, right? When you're having that kind of concurrent hits, so our 3-tier architectures and even multi-tier architectures are having challenge, right? And the world is moving into that kind of level, right? It's not about 10 concurrent users, right? Concurrent means same second number of users are accessing my application, right? 32 million, right? So when that number of concurrent users are high, you will have to have more powerful way of accessing. You will have to have a better the content delivery network, your caching, right? Your CDN, right? You will have to have load balancers. You will have to have multiple layers. So that involves so much complexities in serving that particular one request, right? So sometimes multi-tier architecture is a solution for them. I'm not saying that is the only solution, but that's a one solution, right? So here advantage, we can scale, right? So this can scale into thousands of users. This have because there's no separation concern, right? So it's already separated into so many parts, right? And some of things are reusable, right? Now example, you might not know, but there's some DB, right? DynamoDB. It's a database, right? Here there's a database, here database, and probably another place we can have database. So again, the technology is reusable, and some solutions are reusable, right? So this is, and this provide a lot of flexibility, right? And this is extremely secure way of doing things, right? Like like breaking something is very tough, right? And probably here itself we are spending money to some security softwares, those things, that's very powerful, right? And so what are the disadvantages, right? I don't have to tell you, right? Even by look at this diagram, you see it's very complex, right? It's very complex. The performance can have a issue, right? Even though I'm saying it is a very good performance, if you do it, if you have not done it in a correct way, it can have some performance issue, right? And deployments are extremely complex, right? When you are deploying, you develop something and you want to deploy, you know, it's very complex, right? I don't have to tell you, right? And it's a lot of cost, right? Every place it might be a physical hardware, it might be a VM, so it's costly, right? And integrating these are challenge, right? So I know, right? Don't get confused with some of these keywords, the buzzwords, the softwares, and those things. So if I want to take back, what I want to tell you is, we used to have this two-layer architecture where database and application tier. So your database and your presentation on the logic layer, we understood that that is not enough due to various reasons. So we have moving into our famous 3-tier architecture. This is a solid thing, right? Even now we are doing enterprise level application using this method, where we have your database, you have your logic, you have your web tier, which is a good way to segregate your static content and the dynamic content. So this is have a better performance, the more secure way of doing things. But because of various reasons, right? We have moving to multi-tier architecture, a very complex architecture, but it's multi-tier, right? So it's not a flow, right? Your user, web tier, the application tier and database tier, now each are interconnected. There are a lot of dependencies. So this is the answer for a more complex solution, right? Probably assume that it's a eBay, right? Maybe Amazon.com, right? So these are the solutions for that kind of setup, right? Okay, quickly, I'm just, did you mention the presentation you're going to make major role on interface, right? For example, if you are trying to make a website simple and with some I'm not going to use using 2 actually, okay. Is there a way, any way to overcome the reduce the lack of performance when it comes to complex artists? Obviously, right? Okay, so so part of some sessions we will talk about it, right? So again, what I'm saying is, if there's a business requirement and if you are going to develop a solution, there's nothing like just because multi-architecture is the nice thing and that will show you that you are expert, that is a good thing to have in your CV, that is the way to do, right? Probably even a simple 2-tier architecture will do the job, right? Assume that only 10 users accessing your site, right? Why you go to, we can still make it a little more secure and all, but probably 2-tier architecture is good enough. But if you're hundred of users, there's a concurrency, and there's a lot of secure data, right? So assume that your the business problem doesn't have credit cards, like very simple thing. It's static, right? So maybe we'll live with this. But if you have more of the security is more important, but there are quite a few the concurrent users, and you want to expand, right? Probably I'm starting a startup, and but I'm going to get 100 users per hour, but I have vision, right? I will have million users in future, right? Probably I might invest more for 3D architecture and then evolve. Or probably I might develop a multi architecture, right? So answer is I'm sorry if I want to disappoint you. There's no right and wrong, right? There's no the example. If you get this is a solution, right? This if there's no specific answer, right? It's depend on the nature of your problem. It's depend on what we're going to deliver, and based on that we will have to weigh our pros and cons and then come up with this solution, right? And one thing I want to highlight here is, even in multi-tier architectures, cost is a big factor, right? It's very costly. Why costly? Because we might have to have our physical servers, right? VMs, and again, like we'll have to have a lot of development teams, and so this is costly, right? So that's why we have this evolving concept called serverless, right? So I'll make it a little bigger so for you to see. So this is a serverless, right? So serverless is we are taking entire infrastructure out of picture. I am not going to worry about infrastructure, right? I am just going to worry about my business problem and my business solution, and then that's it, right? So example, this is a system infrastructure design for to-do application. To-do application is a simple to-do application, right? You add a to-do task, right? Tomorrow I want to get up at 6 p.m. After get up, I want to do exercising. After that, I want to check my emails and send the email, right? That's you add to do, right? Then you ask your completion, right? Tomorrow I get up 6 o'clock, I go to application, I wake up, right? I complete it. Maybe after some time, I don't want to keep that to-do task, I delete it, right? I want to see all the when I wake up, I want to see all the to-do tasks, right? And maybe I want to update a particular to-do task. I initially thought that I want to wake up at 6, but I'm little lazy. I want to wake up at 6:30, right? Probably these are the different modules of your the application, or these are the different methods. So it can be anything. So we are only focusing on developing this, right? I'm going to focus only on developing my to do function, complete to do task function, delete to do task function, get all to do function, right? And then I'm going to put this into like AWS providing AWS Lambda, and I'm going to integrate this with Lambda function, and that's it, right? I entire managing scaling is AWS problem, right? So example, if you are, there's a very good site in online called Cloud Guru, right? www.cloudguru.com if I'm not wrong, right? So there are a lot of the videos, right? It's paid as well. So there are people who can come and learn about AWS, Azure, Google, and all, right? So initially they developed this application using probably like this, right? Maybe a multi-tier architecture. They thought about a lot of about caching, those things. So now when they are initially 100 users access, 1,000 users access, 10,000, 1 million, right? So what they are doing, they're adding more compute power, right? End of the day, everything comes down to CPU, memory, right? Your request has to have processing power and memory, right? Those are the two singular thing, right? So then they realize, it's not possible, right? They have to have separate teams managing, and they are not only now focused on developing, but they are focusing on how to deploy and managing as well, right? So that is a challenge, right? And that is a challenge, and that is a overhead, that is costly. So what they have done is they move entire thing to AWS, and from there they went to serverless, right? So they are only focusing on their modules, right? Loading homepage, like viewing YouTube, the video, right? Registering, payment, right? And the course, the structure, something, right? So they go and deploy it. So now, so this is we call a pay as you go solution, right? If only one user access, we pay 1 rupee to, I'm just hypothetically saying we pay only 1 rupee to the AWS. assume that if millions of users access, we might only have to pay based on that request. Maybe it's around one multiplied by something, right? So and if tomorrow, assume that each request worth 1 rupee, right? So today I got 100 users, 100 requests, so I have to pay 100 rupees. Tomorrow, Monday, right? Monday is Monday is the time where people start thinking that office or they learn start. So there are 1 million users access. Maybe only I have to pay 1 million, right? So the week period it will come down, right? So now I just have to pay based on number of requests. So I don't have to worry about the servers. I don't have to worry about the complexities. I don't have to worry about scalability. I don't have to worry about the security. So up to a certain level. So it's a very effective solution, right? So that's why people call the serverless is a very good solution. It gives us a higher cost efficiency. It's again scalable because AWS is managing. It's reduce operational overhead. You just have to worry about what you do, right? You're coding. I'm not going to worry about how to deploy this, right? Again, we can do rapid deployment. Availability, fault tolerance is not my problem, right? I'm just sending the create to do task request to AWS. If I send one request instead of if I send millions of requests, it's AWS job to scale, AWS job to ensure that it gives me the accepted performance, right? I don't have to worry, right? So the auto scaling, those things, again, everything AWS taking care of it, right? So it has a lot of advantages and it has some disadvantages as well. For example, vendor lock, right? My solution is depend on AWS, and maybe I'm not able, if there's issue, I'm having trouble debugging, right? There's some complexities. So the every solution is not perfect, but this is the way where people world is moving, right? So people world wants to get rid of that infrastructure cost, not to have multiple tiers, so not to have so many layers of things, not to invest money on like the computers and with high processing power, RAM or VMs, right? Just to go serverless, right? So this is again will not applicable for all the problems, but this is a good approach, right? So this is where the world is moving, right? Any question, anyone? Okay, so one question is, if you are making a website for banking system as a project, so for transaction processing and for backend data storage to ensure security, then we consider these kind of things. It is necessary to use 40 architecture. So I'm saying yes, right? Yeah, obviously, example banking, right? So what is the most important thing for bank? Security, right? You will have to have a more secure way of like managing things, right? Because you have your credit card, user's credit card. So example, and your the personal detail. And if you can able logging into my banking application, then you can do transfers and so many things, right? So the security is very important, right? So that's why they might want to go into the 40 architecture or even a multi-tier architecture. Second one is you want to have fast response, right? If you are viewing and you don't want to wait for rendering time, so the performance is very important. And again, based on different needs, right? So that you might obviously don't want to go with a 2 tier, and even a 3 tier is a bad thing, right? You need more of a control, right? So that's obviously one good choice to move into a 40 architecture. And obviously, right? So this question is, can we move from a 2 tier architecture to a 3 tier or serverless, the multi-tier architecture in AWS, right? So it's again the way how you have defined, right? So assume that, like again, I'm just tell you like we will do a AWS basic, right? So some of the things I tell you will make you sense. Now we can have a EC2, right? A server, right? We can have one database and one Apache HTTP server. And then if I want, I will add another EC2 instance. I will deploy kind of like so here then I will have my MySQL in a EC2. I will have my WebLogic in another EC2. I will have another EC2. I will have my Apache, right? So that will be a more efficient way. right? So again, AWS is providing, right? And with AWS, it's more scalable, right? Now, in traditionally, right, if it is in a data center, I want to double my capacity, I'll have to order CPU, servers, and someone has to go to the location, cabling, and now with AWS, with a one click, I can add more memory, more CPU, more space. So that is more faster, right? So obviously, AWS is allowing us to more efficient way of scaling and providing these solutions, right? So very high level, I'll try to cover do a comparison, right? So this is a comparison, right? Your two-tier architecture, three-tier, multi-tier, serverless, right? So if you see, serverless is more of like, ticking most of the box, right? Multi-tier is, again, very good, right? Three-tier architecture have its own pros and cons, right? And then two-tier architecture have some challenges, right? So that I'm saying. So if you ask me example indicator for this solution, what I'm going to do for this particular business creator, banking, e-commerce application, government, NGOs, and telecommunication. I can't say, okay, for this one we'll have multi-tier, this one will have serverless. So it's again depend on your business need, your business problem, and how much money your customer is having, and what is the best way to do this, right? So again, I'm saying from three-tier to multi-tier to serverless, going to AWS is a no-brainer, right? So AWS or anything place cloud is a no-brainer. But inside AWS, are we going to use which tier? It's depend on that particular problem statement and based on the investment, right? Money we going to put, right? So with this, I will try to close my session. Any other questions, anyone? So what I want to tell you is that, I think the team has created a WhatsApp group, right? So it doesn't mean that, you will have to ask questions now. Feel free to ask any question in WhatsApp, right? You can, ask anything, right? If you know the answer, we will share you, and we will try to give you as much as data as possible. So one good thing is like, share that your question there. And when you are sharing, don't feel like, there are no good question, no bad question, no intelligent question. There's nothing like stupid question, foolish questions. Every question you will learn something, right? So feel free to ask. If we know the answer, we will try to give you. If you don't, we'll try to find out and give you, and we can make an engagement going as well. Okay, so I don't think, you guys are in the mood to ask questions over the, like, in the like more of a, like, stop me, and but so use the chat feature and all. If there are questions, we can answer as well. So with this, I'll hand this over to Kapila, right? Who will walk you through about the CI/CD and some of the DevOps matrices, and very importantly, the POC, the case study which we're going to drive. And today, like, I know that, I know the mindset of you guys. You guys really wants to see something is working, right? You might probably tired of lectures, and so we are created some demo which will show you. Idea is not to prove that, we can do something, but idea is to get you to realize how simple things are, right? So one thing I want to take up is, this is not complex, right? This is not rocket science, right? So this is very simple things, go into your basics, understand the concepts, and always try to make it a very simplified solution. Simple things, play around with simple stuff, then, you will not make much mistake, right? With that, Kapila, can you take up?
Sure, India. Thanks. So, hope my screen is visible.
Yes, Kamila.
Okay. Okay. Now, actually, I'm going to talk about CI/CD in high level, and also we'll be discussing our basically case study. So how we're going to design basically the deployment architecture of the case study. And I'm pretty sure you have everyone actually. So Yeah, so you must have like read this what do you call the proposal, right? So if you like go through here, like you can see, right? So these are the things that we have to like achieve, and so basically, we have to like create an infrastructure, and then we have to like design CI/CD, and also we need to create a K8 cluster, and also we should have disaster recovery plan, securities, and as well as we need to like we are hoping to include monitoring part as well. So we will basically discuss these things, and we will like show you how to basically come up with the architecture, the deployment architecture to basically achieve this entire use case. Uh, so so basically, yeah, before I move into the designing part, I would just want to like basically talk about CI/CD in very high level. So basically CI/CD is a kind of a like method to like uh, deliver your application changes to customer, right? So there will be like several stages of this process. So this entire process called CI/CD, and CI means continuous integrations. That is, like as a developer, so we have to like we do code, right? Coding, and then so this CI means like actually, so we want to basically build our code, like convert into binary, and then we need to like test the functionality that we have like developed in the code base, and also after that we want to merge or publish into a shared repository. That is basically the continuous integration, that is CI. Okay, so assume if you are in a project and you have multiple developers, so everybody like basically work on their modules, their task, and they get the task, and they implement the required, they do the changes to the code base, and they can actually validate the whatever they have developed, right? But like you want to make sure you don't any introduce any bugs, right? So it might run in your the system, like the local machine, but you want to like actually push into shared what do you call shared repository, and then you need to integrate your the piece of code into other changes to, and you need to basically test end to end, right? Not only the small the changes you have done, but you want to basically put that into the system, the entire the complete application, and make sure everything is working fine, right? So that process basically is CI, and using CI actually you can get several benefits. I will discuss in detail later in the next slide. And in CD actually we have, so first one is continuous delivery, and the second one is, as you can see, continuous deployment. Continuous delivery means like you complete your code, and then you basically tested that and upload into a repository. Okay, that is delivery. Okay. If you talk about deployment, so the whatever you have uploaded into repository or some location, you need to push that into the environment, production environment. Okay, you understand, right? So CI means you build, test, and merge. Yeah. So as you can see, build, you basically you got the code, and then you build, and then you test it, and then you merge into your code repository, whatever. And CD, continuous delivery, means you push that into a shared location. Okay. And deployment is you are going to deploy that into an environment, production environment. In CD, actually, you can consider deployment in environments like testing and development as well. But if you put into production, then it will be under the actually continuous deployment. Uh, so So these are the few benefits actually I've just listed down. As you understood, like we basically do small code changes, and then once you have done the changes, you have to go on through the process. So then it will make sure you uh, you know basically the whatever written, the small piece will be tested, right? So that is the one benefit you can basically get from CI/CD. And also second one is fault isolation. So meaning, like, since you're basically like applying small changes, and then you're trying to build and integrate. So once you are introduce an issue, so you can like isolate, right? So okay, you can understand, okay, there's issue, and this code piece might be the cause in that problem, right? So in that case, you can isolate the issue, and also it will reduce MTTR as well with CI/CD. So meantime to this, like, MTTR is basically um, as I mean, since you have understand, like, you can get notified as soon as you broke some break some functionality. So it will basically help you to fix that issue immediately, right? So then it will basically help you to reduce MTTR, and as well as since you're uh, it will help you to improve test reliability, because you are doing small changes, and you are basically going through the process, and you are verifying the changes you have done. So it will help you to basically improve your test reliability, as well as obviously faster release, right? So you can actually push changes to the production immediately, right? Rather than waiting days and months. So you can simply sometime maybe multiple times within the day. So yeah, based on your need, actually you can increase your reliable release cycle. So as soon as you fix some issues, you can simply deploy in production, and it will help you to improve your customer, right? Happy your customer, definitely. And also it will help you to actually reduce the cost, because you don't want to hang spend too much time. As soon as you found issue, you can fix, as well as you can as soon as you fix something, so you can simply deploy into production, so it will reduce the cost. So these are the kind of high few benefits that have listed down. You can search on Google and find out more things. And so before I move into the designing part, do we have any questions in CI/CD? I simply touch CI/CD in very high level. Okay. Right. Since we don't have questions, so I'm moving to designing. Actually, this designing, I mean, I want you to actually speak, right? Because this is kind of a discussion, like interactive session. Because so I, you know, rather than getting in inputs and getting feedbacks, it's difficult to understand your thoughts, right? So please speak, and because I want you to engage with this um, process, right? So okay, right. Hope you can see my screen. Actually, Indika explain you the different architecture modules, right? Architecture patterns. So, and we talk about two tier, n tier, right? Three tier likewise. So as part of this use case, the case study, so we are going to develop a small REST-based service, which will be in Spring Boot. And also so we are going to actually use MySQL as our database. And also if time permits, actually we will focus on developing front-end module as well in Angular. So this is a kind of the proposed high-level architecture of the application, the POC that we're going to develop. So as you can see in Spring Boot, you can see several layers. So I just highlighted the repository service controller, and in front end also we have control and view, and yeah, so we are going to actually use JDBC to interact with the database, MySQL database, and also we'll be using REST endpoints to basically push to data to front end. So we are going to use REST endpoints. This is the architecture of the use case that we're going to develop. Any suggestions you think you can basically improve here? I seriously want you to actually speak, because as I said, it's a kind of a interactive session. Anyone can like highlight any issues, any suggestions to improve anything? Since this is a small application, so I just came up with this design, but still you can actually suggest, you can highlight improvements. I think we discussed different architecture styles, N-tier and 2-tier, 3 tiers likewise. And also we discuss serverless. Any suggestions, team? No? You think this is perfect solution? Okay, so I think, yeah, someone has sent a message chats, but yeah, I can read the questions, but I really would like to hear your voice, Saleh. Can you just unmute yourself and ask this question, please? Are you in a position to unmute yourself? Ashwin, can other participants can unmute yourself, or have you like restricted?
No, they can unmute themselves.
They can unmute, no? Okay. So don't worry, team. Like this is not impacting your final year results, your exams, right? Your job. Like some people are basically doing job, but this doesn't impact your anything. It's a kind of a session, kind of a knowledge sharing session. But please, like, speak. Then only actually I can get understand, like whether you understood this thing or not, right? So, but to answer your questions, but yes, we can use. I will show you actually. We can use AWS, obviously, yes. Okay, right. So next step is to design our basically deployment architecture, right? And okay, I'm going to use this tool to draw a diagram. Let's say we have so developers, right? Okay. We have multiple developers, and so these people are working on code base, and then so I assume you have heard about Java, so and Spring Boot, MySQL. This is stack basically that we're going to use to basically to implement this use case. And let's say you're basically developing this use case in Java in Spring Boot, So you have to basically host this code, right? You have to like push that the source code into some repository, right? So what are the code repositories publicly available in you know you can use code repositories you can use for this exercise? Basically code repositories are like the system where you can host your code, source code. You think you can what are the publicly available systems? Okay, Minol is saying GitHub. Can we use GitHub? So Minoli, why do you say you can use GitHub? Okay. Okay, what else thing? Okay, Minoli is saying GitHub. What else? What are the free code repositories you can use? Yeah, there are many actually. Yes, GitHub is one of the famous one, and you can use what do you call Bitbucket as well. JetBrain, not really sure. It's a tool actually, IDE, JetBrain idea, and also they have a CI/CD tool as well called Team City, but not really sure that they have a code repository. I haven't used actually, but yes. Okay, let's in this case we'll assume we are going to use GitHub. Okay, the GitHub repository. Okay, you push your changes to GitHub. Okay, so now let's assume you build a functionality and test it, it's stable, and then you push code into GitHub, right? Assume, so just think like what you need to basically achieve. So you need to deploy this, basically you need to implement CI/CD, right? CI/CD pipeline for this particular use case, right? That is your end goal. Okay, so now your code is in GitHub, right? What is next? Then now you need to think how we can basically pull this code and deploy it into a environment, right? Let's assume this is your environment. This is your server. Okay. Let's say we are going to use AWS, right? This is your AWS environment. Okay. Here you will have multiple VMs, right? Okay, VM1, VM2. You have two VMs for now. So your target is to deploy, like implement CI/CD pipeline to deploy this code changes into this VM. Okay, right? Understood? So your code, you have basically push changes into GitHub. Okay, so in right, in GitHub we have something called repository, right? And also we have what you call branches, right? So you have by default you have main branch, and then you can create several branches out of it. Let's say you have main branch, you have only main branch, and you have push the code into repository. Let's say XYZ. This is your repository name and branch master. Okay. Just let me know if you're not clear, right? Since you are not speaking, I'm just assuming you are getting what I mean. And if it is not clear, please ask, unmute yourself and ask, because this is very crucial, right? You need to understand this. Otherwise, because our entire use case will depend on this, right? If you have any doubt, please interrupt me and ask, right? Okay, so XYZ our repository, and then you have basically push changes into your master. Now you need to like find a way to implement the changes into VM1. Okay. Okay. So how do you do that? You need to first, as I said, like you need to find a mechanism to pull this code base, right? You remember, right? Our CI/CD. Okay. CI means what? Build, merge, and build, test, merge, and publish, right? Okay. So this is basically CI part, right? You need to find a way to like push the code changes, push the code changes, and then build, and then you need to, like you should be able to like validate, like execute test cases, and then push binaries into somewhere. Okay. For that, actually, we are going to use tool called Jenkins. Okay. So we have something called tool called Jenkins. Jenkins actually can pull the code from the this GitHub repository, okay, Git repository, and build. If there are any test cases, it can actually execute those test cases, and it can actually build. Build means you can create a binary file, right? Okay, right. Pull. This guy can actually so build and then test and publish. Okay. So let's assume, okay, Jenkins pull the code and then build and then execute all the test cases, and test cases are fail, passing, no issues with the code base. Then it needs to basically publish the binaries to where? VM1. No. Yes, you can directly basically push into VM1, no issues possible. But this case, we are going to do actually some additional thing. I will explain why I'm doing that later. But let's say here you build your code base and convert into binary file, and then you containerize it. So your plan is to basically run containers in these VMs, right? So you containerize it. Here actually we are going to use Docker for the containerizations, right? So let's assume Jenkins get the code, build, execute the what you call test cases, and then containerize and push those images to Docker Hub, right? Because so our target is to publish use Docker Hub as our central repository to host our images. Okay. Simply, as I said, you can simply deploy into VM no issues. But here we are going some additional things, right? So we are basically we are trying to Dockerize our applications and publish in Docker Hub, and from that only we are trying to deploy into VM1. Okay. To do that, actually, we are introducing one more tool called Spinnaker. This guy can actually pull images from the Docker Hub and deploy into your VM. Understood? So in this case, actually, CD part will take care by the Spinnaker, right? Spinnaker is basically CD tool, right? Jenkins here, I mean, we will be using for CI, continuous integration. So Spinnaker will be using for CD, continuous deployment. Okay. This is basically our CI/CD pipeline. Any questions before I move to next? Anything to clarify? I hope I explain why I pick this tool and the purpose of these tools, and I hope I explain clearly. But Unity speak if you're not clear, if you have any doubt. And also, I would say this is not the only the way to implement CI/CD. There are multiple ways, but depend on your requirement, depend on your cost and all that, you can design. But this is the what do you call it, the design that we are going to use here for the use case. Okay. Okay, good. Yeah. So basically, yes, you can. It's like this. So GitHub is to host your code base, right? This is basically a version controller. GitHub is here we are using to host your code base, and Docker Hub basically is to host your images, right? Yes, but you can use GitHub as well here as a to replace Docker Hub, because again it's a binary file null. But in this case, we are using Docker Hub to host images. I mean, these two tools are basically two purposes. Docker Hub is to host images, GitHub is to host your code base. But if you want to push your images to GitHub, yes, possible. But in Docker Hub, you get additional stuff. We'll explain you later. For that, actually, we are using Docker Hub to host our images, because here we are expecting to, create images, right? As I said, create images and host those images in Docker Hub. Any questions? Okay, right. So now, yes, as I said, we have designed our CI/CD pipeline. Okay, I hope you remember. This is done. Kubernetes cluster. Okay, that means we need to do some changes here, right? Because this is not Kubernetes, right? This is just VMs in AWS, right? CI/CD done, but we want to do some enhancements here. This our our environment, right? So I'm going to actually convert this into K8 cluster, right? K8 means Kubernetes cluster, right? So I'm going to create, because here you remember, right? So we need to basically create cluster, right? Kubernetes cluster. Move this. I will create. Still, I'm using AWS. Okay. I'm going to create Kubernetes cluster. So in cluster, I want actually 3 nodes. I'm trying to I'm creating 3 nodes. Yeah, this is my node 1. This is node 2. This is node 3, right? So in my cluster, Kubernetes cluster, I have 3 nodes. Okay. So this node 1 is my master node. This is master node. This is master node. Okay. These are called worker node. In a cluster, in K8 cluster, we have something called master node and worker node, right? So don't do like we'll have like 8 session in I think within the next couple of weeks, but just understand the idea. So in K8 we have something called worker node and master node. The applications, the whatever we deploy in Kubernetes will be hosted in these nodes only, right? Worker nodes only. Basically, master node is the one who actually manage the cluster. Okay, so I mean, it won't have any the applications, right? So it will have only the K8 services, right? But the Java applications and all this will be here in worker node. Okay, so in our cluster we have it's a 3 node cluster, single master, and 2 worker nodes. Okay. So yeah, so in that case, we need to like change our Spinnaker to deploy our what you call application into K8, right? So we can't use uh, the AWS the pipeline we have created for AWS VA. We have to modify to Spinnaker pipeline to deploy the changes into our K8, right? So we will discuss in detail later, but just remember. So you need to configure Spinnaker to deploy changes into K8, right? So now, yes, we have actually created what you call Kubernetes cluster. Okay, so let's say we in worker node 1 we have our what you call REST service. Yeah, so we have REST service in worker node 1, and here we have what else we need, REST service, and what else? You remember this architecture, right? This will be in worker node 1. Then what else we need to run this application? Okay. Since you're not speaking, so we need database, right? Yeah, MySQL. Okay, so in worker node 2, we will have MySQL, right? So this is basically our Kate architecture plus CI/CD pipeline. In addition to this, actually, so we are going to implement monitoring as well, right? So for monitoring, actually, so we'll be using Elk stack, right? That is Elasticsearch, Logstash, Kibana, and this is for log monitoring. Log monitoring, we have Elk. For metrics, we'll implement Prometheus and Grafana. Okay, so this will be our final deployment architecture, right? As you can see, GitHub, and then we have Jenkins, Docker Hub, Spinnaker, and we have created 3-node Kubernetes cluster, master node, and 2 worker nodes. So in worker node 1, we have a Spring Boot service running, and node 2 we have MySQL, and also we have created basically deployed Elk stack plus Prometheus Grafana for monitoring. Okay, this is the deployment diagram, deployment architecture that we are going to implement as a part of this case study, right? So don't worry, like we will conduct sessions to basically talk about Elk stack, Prometheus, and also what do you call Jenkins, Spinnaker, Kate. Have several sessions to talk about these tools, and this is the basically step to give you kind of high level idea. So at the end, what we are going to achieve. Any questions? Anything you want to like clarify? Any doubt? Any challenges? So why you have done this, and any if you want to like highlight different ways of or any issues with this architecture. No? Okay. Okay, going back to PPT. Okay, these are the things kind of like if you can cover like I know some of you have like actually learned Linux, but if you can brush up your knowledge, and also if you can develop simple REST service, maybe using Spring Boot, it will be really helpful. Otherwise, we'll basically share you kind of like sample GitHub repository with the code base, so you can reuse that as well. But if you want to create your own REST service, you can create and you can develop and push into GitHub. These are basically kind of like exercise you can actually work on during next couple of days until we meet next week. Yeah, that's about from my end. If you don't have any questions or anything to ask, I will hand over the session to Mohan to demonstrate basically CI/CD pipeline. Thanks. Mohan?
Yes. Okay. So this is the high level design what we have implemented in CI/CD pipeline. So there are some developers. Let's say in here I have mentioned 2 developers. So there may be multiple developers. So they are using their local machine. And in here, AWS code commit is something like similar to Git repository. So this is the service provided by AWS. So we can store our codes. And so these developers or these users are store their codes in code commit. So this is a centralized location. And whenever they want to do any kind of changes or they want to do refresh or update their repository, then they have to clone it first. Once it clone it, then they can pull the new content or new updates to their local machines, and they can work on their local machine only. Once the changes are done, they can push the new updates to code commit. So this is the where that CI is coming. So you can, I'm not the complete CI part. So this is a part of it. So once you done the changes, and it will be stored in this repository. So I'll get back to code pipe in a bit. So this is the uh, Amazon S3 bucket. So we are using this as a static website. So these are the end users who are accessing this website. So accessing this S3 bucket, but we can assume this is the our website. So in code pipeline, or let's say now you have a website, and the final code or the changes are stored in this code repository. Now, how you can develop or deploy this code to S3? So the solution is code pipeline. So in here, it will listen to this code commit, and whenever any changes happen, automatically it will deploy this new content to the respective server or the particular box. Then in here, this is the S3 bucket, but this can be a server or EC2 instance, or else this can be a serverless option as well. So in here, this is a simple workflow to demonstrate how the CI/CD will work. So before that, I'll quickly go through about the prerequisites as well. So if once you are practice this in your free time before the next sessions, then you will get an idea how to do that. After this session, I share the useful URLs or the artifacts, so you can refer that as well. So in here, you need to, in the local machine, you need to install Git. Then you need to in the AWS, you need to have a account. Then you can use AWS services. And then you need to maintain at least one user, and you need to provide relevant access or the relevant permission to access the services. And you need to create a code commit repository in AWS. And next thing is you need to create in here I have created S3 buckets, but as mentioned earlier, you can create any mechanism what you want. So if we go through this diagram, then you need to create a S3 buckets, and you need to provide public access. And once done, you can create the code pipeline. So once the code pipeline is created, then the workflow will be established. So, and another thing to highlight, you can do this in your free tier. So no need to pay any extra fee. So without any extra cost, you can test this by yourself. But there are some limitations and conditions applied. Like you cannot, based on the usage of this code commit, then it will be charge you. But if you test at least 3-4 hours with some concern rate of file size, then you won't exceed at least $1. So it's pretty efficient to do it yourself. And that's all. Let me open the browser. Okay. So in here, this is the code commit. Or in here, I have already deployed 3 files. So let me refresh it. Okay, in here we have error HTML and 2 JPG files. And if I go to the pipeline, so in here we can see the pipeline is working fine. So all are green. And so there are no activities done within last 2 hours. So no changes were done. No, this pipeline didn't executed. So in here, I have created only a deploy stage, but when it's come to the product, the industrial level, or based on the your thought or your plan, you can add in at any phases. Like you can add a build phase, so you can do your build, and then after that you can add another stage for testing. Then you can uh, uh, link this deploy. So the workflow will be from the source. It's our commit code commit repository, and once any codes are moved to code commit, then it will identify, then it will build the code, then it will do the test, then only it will be deployed. We have a control of controlling this activity, so we'll discuss in later. So this is our S3 bucket, or we can call this as this is our uh, website. So in here, the same as in the code commit, we can see that 3 file. So this is the URL of my site. So if I try to access it, it will throw an error. Why is, if you closely examine, then you will identify index.html is missing. That's why it's given an error. It doesn't matter. So it's also a part of configuration. This is show. This will execute this error HTML. That's all. So what we are trying to do it here. So in my local machine, I'm going to push HTML index.html to the repository. Then it will automatically pick by the code pipeline. Then it will be push the update to our website. Then most probably this should work. So let me open my console. So currently I'm in demo. So this is my uh, local repository. This is my machine. So I can see the same details, the same files are stored in my machine as well. Error HTML and 2 other JPG files. So I'm now going to copy this index file to this, and we are going to proceed to the code repository. So let me copy it in here. Okay. Okay, now we can see index.html is in my repository. So what I'm trying to do is, now I'm going to first, as mentioned earlier, we need to understand we have the current, the latest update. So I'm going to run git pull command. So it's saying that already up to date. Then I'm going to git add the file name. So it's index.html. Then git commit -m and the message. So I'm going to add that the index.html file. Okay, now it's added. Now I'm going to push it. So git push -u origin me. Okay. So it's now push the data. So if I go to my repository and refresh it, Now I can see that index file is appearing here. So if I check my code pipeline, now it's just now executed. Succeeded. I mean, the pipeline is correctly worked. If I go to my S3 bucket and refresh the content, then I can see the index file in here. So if I refresh this, most probably it should, okay. Now I can see my index file. I mean, it's refer the index file and I can see the content, hello world and the picture. So if you want to do any kind of, this is the situation where I'm adding a new complete file. So again, if you need to do any kind of changes, let's say if you need to change this index file, then let me quickly change it as well. So in here, I'm going to change the JPG name, then can identify the changes. As I remember, it should be tower. Okay. Great. And let me save it. Okay. Now I have done some changes to the local machine. I mean the index file which is stored in my local machine. And again, I need to follow the same process. Add git add index git commit and the file .html. Okay, then git push -u in me. Okay, then okay, successfully executed. So now so there are no any changes in the code commit because we just changed the content of this index file. So let's move to code pipe. Okay, now it's in progress. It's executing at the moment. So let's wait for it completes. Okay, it's success. Okay, both are success. Now if we refresh this demo Mohan, again we can't see any changes because the file name is same. So this is the picture we had. Now if we refresh it, then it will move change the picture. So this is the simple pipeline where whenever we do any changes and push the update to our Git repository or the code commit, then automatically a pipeline will pick that change and deploy on behalf of us. So this is the thing we need to demonstrate. So you may have, so let me quickly show you the users as well. So I have created two groups. And in the admin group, I have the admin user. So I have provide relevant access to the group, not to the user. So as a best practice, if you need to provide any permission, then should provide to the group. And so using this permission, we can do this activity. And one more thing, so you need to create some roles as well, but you don't need to, if you are new to AWS, then you don't need to bother on the roles, because whenever you are creating this code commit and code pipeline, by default, it will ask whether you need to custom create this what do you call roles. If not, then it will create on behalf on behalf of you, so you don't need to bother about the roles at all. It will create and it will link correctly. So just you need to create these tools and make sure that the configurations are correctly configured. Then obviously just do some tests, then you will understand whether it's working fine or not. If there are an error, you can easily Google it and identify the error by yourself, or else in the group chat, you can post any issues if you are observing and if you need any help. So we are happy to help you. And as I discussed, I'll share the required URLs and documents or the tutorials with you, so you can refer those and you can create this pipeline by yourself. So do you have any questions? So there is one question. So in the AWS, you are giving a free access or the some level of free free services. So you don't need to. I mean, you need to understand what are the free packages or the free services you will get from AWS. So based on that, you have to work on it. And again, if you even though, I mean, don't worry about that. You suddenly you won't get any sudden cost. It will be like if you want, if there is a cost for around $1, then at least you have to spend your time on AWS at least 4 to 5 hours with some certain of high usage of CPU and memory. That's only where you will be charged. Otherwise, you can freely work on AWS. So in here, you can, once you create the free account, and if you go to billing page, then you can check how much you have charged. If it's 0, then no worries. If there is a charge, then you can understand where this charges are happening. I mean, what are the paid version you have used to get this charge. In here, charge by service, then you will get a way to drill down what is the exact service or exact so product you have used. So this is for Linux T2 large instance. So this is not about this pipeline and everything. This is free of charge. So this is something else. So in the next lecture, Indika has mentioned that we are having a basic training for AWS as well. So from there, Indika will guide you how to create alerts mechanism. So from alerts, you can understand if you are breaching. I mean, if you are breaching this free tier, then again you can check what are the free services you can use in AWS as well. So in the next lecture, we can discuss that. So any other questions regarding this VIP pipeline?